I'd like to welcome everybody today to the Day of Remembrance activities. I'm really pleased that we have a lot of special guests with us here today, including family members of crew members. I'm not going to be able to call out everybody by name right now, but I did want to point out that we are fortunate to have several of our former JSC Center directors here today. We have Mike Coates, Beek Howell, George Abbey, Carolyn Huntoon, and Jerry Griffin. And if you wouldn't mind, stand so we can acknowledge their presence here today. So as a reminder, after this panel, we invite you all to come out to the Astronaut Memorial Grove, where we will be laying flowers at the trees of all of the members of the Apollo 1 Challenger and Columbia crews. And then we're going to be following that with a tree planting for astronaut Edgar Mitchell, who passed away last year. And I do also want to acknowledge some other great losses that we've had recently: John Glynn, Piers Sellers, and Gene Cernan. And I think you all are aware that Gene Cernan's memorial is in downtown Houston this afternoon, and that will be shown on NASA TV. So I hope you will fall in for that. And so now I'd like to introduce our Deputy Center Director, Mark Geyer, who will start off our Apollo 1 Lessons and Legacies panel.
Thank you. Thanks, everybody, for coming. You know, we have days of remembrance, not just to honor the heroes that made the ultimate sacrifice for the country, but also rededicate ourselves to remembering the lessons from these accidents. Our panel is focused on the lessons of Apollo 1. But before I started, I wanted to ask, if you worked on an Apollo program, would you stand up, please? Just like to recognize those that worked. Great. Awesome. Thank you. Thank you for both for your great work and also for coming out today. You know, I wouldn't be at NASA without what you did, so I want to thank you very much. I also wanted to do one other thing. If you came to NASA after 2003, in other words, you started working here after 2003, would you stand quickly? After 2003. Yeah. So, all right. Thank you. So, the reason I did that is there are a significant number of folks that work at the Johnson Space Center that have arrived here since our last accident, right, since Columbia. So these lesson learned opportunities are really, really important to hear from the folks who actually did the hard work and learned the lessons, and it's really invaluable. So 50 years ago, on January 27th, 1967, the crew of Apollo 1 was performing a checkout test in the Apollo 1 capsule at the launch pad at the Kennedy Space Center. Just for a little context, the last Gemini mission had been completed just 2 months earlier. NASA had a little less now than 3 years to land a man on the moon before the end of the decade, and yet not a single manned Apollo flight had been flown. As those of us that have worked on commercial crew and Orion, we know that with many first flights of a system, there were, on Apollo, several technical issues and schedule delays, so a lot of stress. This particular test that happened on this day was called a plugs out test, and it was conducted prior to flight to verify and demonstrate that the space vehicle ground support equipment, procedures, personnel were all ready for flight operations. Some of the test things were the first time that they'd been done. Now, although the crew was in their suits, in the capsule, and in a pressurized pure oxygen environment, the test was not classified as hazardous at that time, because at that time the only test that included fueled vehicles, hypergolic propellants, cryogenic systems, high-pressure tanks, live pyrotechnics, or altitude chamber tests were classified as hazardous. At 6:31 Eastern, a fire started in the cabin. Within 15 seconds, the capsule ruptured. It took the ground crew a full 5 minutes to get through the 3 hatches to reach the interior of the crew module. Lieutenant Colonel Virgil Grissom, Lieutenant Colonel Ed White II, and Lieutenant Commander Roger Chaffee all perished as the fire consumed the interior of the Apollo capsule. In the midst of the race to the moon, the Apollo program would not fly again for 21 months. Although the board was not able to determine conclusively the specific initiator of the Apollo 1 fire, it did identify the conditions that led to the disaster. They specified the conditions as followed. 1, a sealed cabin pressurized with an oxygen atmosphere. 2, an extensive distribution of combustible materials in the cabin. 3, vulnerable wiring carrying spacecraft power. 4, vulnerable plumbing carrying a combustible and corrosive coolant. 5, inadequate provisions for the crew to escape. 6, inadequate provisions for the rescue or medical assistance. So in 1967, although I don't feel that old, I was only 8 years old in 1967. But I remember watching TV with my dad when the screen came up and said that we interrupt this programming and mentioned that something horrible had happened at the Cape. So I remember that very clearly. You know, we have a very difficult job, an important job here at JSC and at NASA, that in the context of an inherently risky endeavor, we strive to make space travel reasonably safe. I want to thank again these panel members and also Frank Borman. Frank Borman could not come here, but he was interviewed, and you'll see him on the video, so I want to thank him for his time as well. I want to thank them to remind us of the Apollo 1 lessons so that we can continue to do the work that this country has charged us to do. So let me start by introducing a little really quick about background on some of the panel members. So first of all, basically moderating our panel is Nicole Mann. And Nicole, of course, Lieutenant Colonel Nicole Mann is in the U.S. Marine Corps, began her flying career as a naval aviator in flying FA-18s. Her combat experience includes missions in support of Operation Iraqi Freedom and Enduring Freedom, and she was selected as an astronaut in 2013. Frank Borman, as I mentioned again, will be on video. You'll see that. Of course, Frank was a test pilot, fighter pilot, and flight instructor prior to becoming an astronaut. And Borman flew Gemini. He commanded Apollo 8, as we all know. He also served as a member of the Apollo 1 investigation team. Colonel Walt Cunningham, also here today, began flying night fighters in 1954 for the Marine Corps in Korea. He was a backup crew for Apollo 1, and he served and flew as a pilot on Apollo 7, which was the next flight. Gary Johnson managed the sequential subsystem for Apollo and Skylab command service module and Apollo lunar module. He was an electrical power system console operator and mission control at the time of the accident. Glynn Lunney was a member of the Space Task Group in 1959 and served as flight dynamics officer for the Mercury flights. He was a flight director for most of the Gemini and Apollo flights, including Apollo 7 and 8. So, Nicole, to you.
Thank you. Gentlemen, it is an honor to be here, and thank you for joining us. We'll jump right into the questions. The first for you, Glynn. What were the greatest challenges facing you and other members of the development team in the period leading up to Apollo 1?
The environment we had was that we were recovering from the fire, and many of our operators, especially the people who worked on the command service module systems, were tied up with that. So they were not only getting ready to do a flight control job on the upcoming flight, but they were actively involved in all of the things that were going on in the spacecraft and so on. The other thing that we were involved in was the first of Apollo manned flight, which required a lot of extra special attention in the sense that all of us on the team were coming up to the fact that the vehicle was manned. We'd flown a couple of unmanned ones by this time, but making it manned would be different for us. So people were paying attention to that and polishing their skills with respect to what we might have to do during the flight.
And for you, Walt, how was the Apollo 1 test mishap different from some of the other ground tests that you participated in, and were there any specific safety concerns?
Looking back at it, I can't put my finger on a specific concern, although we had a lot of concerns, small ones at the time. But with the attitude of our flight crews and what we thought about flying, we would not have flown if we hadn't thought we could overcome what it was. And it became tougher and tougher to get fixes on those things that we were concerned about because of the schedule you're talking about. There was not a lot of excess time trying to get to the moon before the end of that decade. And so for this particular test, I don't think we had any special concern about, you know, the oxygen or the test. And we had our crew, Wally Sherrod, Don Isley, and I, we had performed the same test the night before, but we did not have the plugs out, so we had external power. The hatch was open, and there was absolutely no problem. It took us about 15 minutes. So the next day, we were all waiting to fly home together. We were going to have a weekend off. That was when they were scheduling the launch at the end of the month of January there, end of February. And we never expected it to be going then anyway. We knew there were going to be some problems that were going to overcome, that going to cause it to slip, and the crew could be better trained to do that.
Thank you very much. For the next question, we had a chance to talk to Frank Borman, and so we'll start out with his response. Tell us about the Apollo 1 accident investigation process.
Well, the great service that the Administrator Jim Webb did was to convince the President that NASA could investigate itself. And as a result of that, he appointed a committee headed by Dr. Floyd Thompson, who was the head of Langley Research Center, NASA Center, and I don't know, 10 or 11 other people. I happen to be a member of it. I don't know. I'm not sure that any of the others are still alive. It's been so long ago. But in any event, it was a massive effort to get to the bottom of what happened and then correct it. And I'm very proud of the work that the committee did. It was scathing in some of its remarks about NASA and about North American, the contractor for Apollo. But out of it came, I think, a path toward a better spacecraft.
Yes, well,
I would like to add that Frank was pretty much in charge with the investigation afterwards. I worked on the investigation for maybe 4 weeks. Frank stayed on it, and I think he did an amazingly good job. Looking at possible changes, the relationship between us and the contractor, the relationship between NASA and the contractor. And Frank was, in my opinion, was the key to having such a perfect solution after that.
thank you. And do any of you have anything to add on what some of those changes were that took place and how we could implement some of those lessons learned today?
One of the big factors was, of course, that the unprotected wiring. It turns out in those days we had a lot of the wiring going across the floors and tied together with binders, but during ground checkout they only had foam covers is all they used to protect it from the crew at the time. And the Teflon wiring we used was susceptible to cold flow. The insulation was, and if you had any physical outside pressure on it, it would deform and so forth. And so one of the big things we didn't realize is in Gemini and Mercury, even though those were pure oxygen environment, the crew was pretty well isolated from making any contact with the spacecraft wiring and so forth. So this is the first spacecraft that you had that situation. And I was over there in those days also. I might point out that the engineering support was actually alongside the flight controllers in those days. We didn't have a mission evaluation room. So you sat alongside the flight controller, and on that particular day at 5 o'clock, most of the flight control team had left. So I was the only one on the EPS console in the SSR, and Mort Silver was on the North American flight controller on the ECS console. And then Dr. Kraft was one of the few that were outside. And of course, we were told right away not to when it happened, to lock all the doors, and we weren't allowed to make any calls except one call to our wife to tell them that we wouldn't be home. And Chris Kraft came back in the SSR and told us be sure to be reviewing the data and going through it. We're going to be going over this all night long. We're going to do playbacks and so forth. I did make a note that at the time the crew reported a fire, we had a short on main bus A and B. And so I realized it must be some diode load in the spacecraft. So right away afterwards, when I went back to the office the next day, I spent time finding out where all our diode loads were. And then 3 or 4 days later, I was sent down for the investigation to go through the spacecraft. And turns out that one of those diode loads was underneath the ECS bay. And studying it had a Teflon overwrap over it. And this is a lower area just below the commander's couch that went over the plumbing and underneath the ECS door. And there was the main bus A and B power dioded to the ECS instrumentation that was in that. It turns out that when you're in there looking at the vehicle afterwards, that whole area was gone because that was the hottest part of the fire. Metal and everything was gone. So there wasn't physically anything to see. So we had to go back and study closeout photographs. I noticed on the closeout photographs, the Teflon had slipped down, and so the wiring was exposed to any damage if the crew had to put their foot down or so forth. The other thing about the lessons learned that came out of that in regards to the wiring, there's a lot of things about the hatch and the O2. One thing you don't hear mentioned, however, is the center put out this directive that any future manned spacecraft that's managed by the Johnson Space Center or the Mann Spacecraft Center at that time, we were going to conduct a management walkthrough inspection, which was a chance for all the engineers from NASA or top managers, top designers, along with the North American or Rockwell designers to actually go through and inspect the spacecraft, particularly for their areas. For example, I was doing it for the wiring. And you did it at a time before the before closeouts were done and before it shipped to Cape. So at that time, we were able to confirm that the metal covers, that was one of the major design changes, was the fact that metal covers were placed over all the wiring, so there's no way you could damage the wiring or plumbing. And they had designed hard flooring that could be removed for the workmen. So when you went in to work on the spacecraft and do things, you had this hard covering that was could be taken out to further protect the vehicle and so forth. And it became important. And so we did those inspections on every spacecraft.
Yes, Will.
I'd like to add one of the factors that people don't talk about too much here, but you did mention the 100% oxygen. Pilots have operated with 100% oxygen many, many times over many years in their oxygen masks. Mercury and Gemini had all flown with 100% oxygen. That wasn't the real problem here with the fire. Everything burns much worse in 100% oxygen. But that particular test, they had been operating on the ground with the hatch closed. It was a 16 PSI, I believe, 15.8 PSI, 100% oxygen. And it was about a 15-minute test, but they had gotten in the spacecraft about 1 o'clock in the afternoon, and we were all waiting to fly back together, and it kept dragging on, 100% oxygen, soaking up anything that was in that spacecraft. So at 16 PSI, that was a big difference, and that's why the fire happened so fast, because everything was saturated and just burned it up like that. And one of the fixes then, of course, we ended up trying to not operate on 100% oxygen. So I think when we flew on Apollo 7, it was about, I think about 60% of the atmosphere inside on the ground was 100% oxygen.
And let's talk more about some of those safety changes that were put into place. We'll start off with Frank on this next question. What were the safety process changes after Apollo 1, and how were they helpful to the success of the rest of the Apollo program?
safety were changed?
Well, there were an enormous number of changes after the fire, and the committee recommended some. A lot of them were in management. The Apollo program at NASA Johnson was sort of an anomaly because Joe Shea, who was the project manager for Apollo, reported to Washington, and he did not involve the resources that existed at Johnson the way he should have. He didn't keep Dr. Gilruth, who was the center director, informed as he should have, and it was almost as if the Apollo cadre thought, well, we know best. We're a little bit better than everybody else, and so we're not really interested in what happened in Gemini because we're going to do a much better job. That was as much a part of the problem as anything in my mind.
And Glynn, what are your thoughts about these safety process changes?
I was a young foot soldier when Apollo came along, and I must admit that as I gradually got a sense of what was going on in the Apollo program, it was as if after flying Mercury and Gemini with a relatively small contingent of people, we got into Apollo, and it was like we had a national mobilization going on. It was big. Everything was big. There were contractors for everything, and it was, you might say, overly block diagrammed in terms of the organization. It just too many people, and there was a lot of overlap with it, and it scared people. One of the stories that I have from Chris Kraft, just to give you an idea of what things were like at the time, somewhere in the early 60s, Dr. Gilruth asked Chris to go out to the what was the Rockwell plant, Rockwell in modern terms, North American at that time. And when Chris got out there, he attended a meeting that was conducted by the program manager for Rockwell, North American, I keep calling him, and for NASA. And it was astounding to Chris. It was a full-throated argument that went on for the whole meeting, conducted not in English but in a foul language that did not help the situation. And it was kind of scary. And the environment was such that there was a lot of that going on. And actually, in my view, it changed after the fire. It changed some as we went along, but it changed dramatically after the fire. George Lowe emerged as the program manager. Bob Gilruth was put back into the loop. He had been ignored and pushed aside during the run-up to the accident in the Apollo circles. And there was an attitude that we're from Washington and we know better. And we just finished the Mercury project and the Gemini project, and then we were faced with entering this world where, the employees and the contractors were measured in the multi-thousands of people. And so it took a little getting used to on our part. But Bob Gilruth suggested George Lowe as the project manager after Joe Shea resigned. And that was a stroke of genius. I think even today, looking back, most people who were involved would say that George Lowe brought the program out of despair and brought it into the sunlight. This happened, 5+ years, almost 6 years, the accident did, after President John Kennedy's speech starting Apollo. And that's a long time to be messing around with a clunky organizational problem. And it took the fire to straighten it out. And once changed over to George, and by the way, George Lowe represented this center as the Mann spacecraft center to the program in Washington, and he was responsible for the spacecraft itself, both of them. and for all the other associated things associated with flying, flight ops and the crew ops. So looking back on it, I would say that George Lowe came along as a savior. Bob Gilruth was reinstated. Bob had a great deal of experience. He wasn't popular with the new people because he was not flamboyant enough. But he was sound as the devil. And as a matter of fact, when they turned to him after the fire, he turned around and suggested George Lowe as the program manager. And from then on, it went fine. I mean, within 2 years, we flew Apollo 7 and Apollo 8, a hallmark of a decision that George Lowe pushed back in the time. And it was quite a process to see. We came out of Gemini. We knew all the things that we had to learn coming out of Gemini. We were ready to fly, and then we had to go on hold while we recovered from this accident, both physically, safety, and emotionally for all the people involved. But God bless us. If there's a message in that is the people and who they are and how they are probably as significant as all of the mechanics of our business. We don't really have a process in place for evaluating that. It's not, you know, I know we have performance appraisals, et cetera, but it's interesting when you look at it for NASA, who has process for everything. We don't have a process to be sure we got all the right people in place and that they're staying on track. Maybe we ought to have such a thing. I don't know.
That's a great point with the people, and specifically the contractors. I know, Walt, you spent a lot of time working with the contractors. Can you talk a little bit about that relationship and how you develop that, and maybe some advice you have on how to resolve points of dispute?
Well, I'm not sure that anybody pays attention to any advice I might say. But my analysis is that one of the major improvements after the Apollo 1 fire was the change in the relationship between the users and the contractors that were doing it. I worked on what you would call Block 1 spacecraft for probably a year and spent a lot of time out with the contractor, and mostly the contractor was able to keep control. It was before the people that you mentioned were getting involved, and so we had to live with a lot of things that we tried to change on it. And then after the fire, the whole attitude, it didn't change incidentally, because Rockwell, North American, they still at the time wanted to maintain their control over what was going on. They designed many, many good airplanes, and then they just stick a test pilot in and he'd have to go fly that particular airplane. But from that time on, when changes came up, NASA had a lot more say-so on it. And so at the time, as astronauts, we were out there on the flight crew, and we were living with the design of this. The vehicle was not just something you could go and climb into and go fly. So we're still designing it and going through the testing, installation of various pieces. And I'll never forget, there was one time when the schedule kept slipping. Look at 21 months that wasn't planned to be involved in there. The schedule kept slipping, and the head of the North American at the time, he was complaining to Dr. Gilruth, and he said at the time that the schedule keeps slipping, and you've got these guys out here, and they keep talking about various changes. The astronauts are living with us here, and they're slowing us down a lot. So Bob Gilruth replied, he says, well, that's okay. We're not charging you for their time. I never forget that.
Thank you, sir. And you mentioned schedule and the pressure of schedule. Let's go to Frank for this next question. And it's, did the schedule pressure of trying to get to the moon by the end of the decade contribute to the Apollo 1 accident?
You know, I'm a firm believer in schedules, and I think President Kennedy not only did a very courageous thing when he announced we were going to the moon and back, but he also, I think, did a very smart thing when he put a time limit on it. The fact that there's a requirement to get things done is an important an important milestone in any.
One thing I
Your
might
thoughts.
mention is Gilruth also did a major organizational change within the reliability and quality assurance organizations reported up through the Apollo program office. And so one of the major things Gilruth did is reorganize such that the reliability and quality assurance and safety function reported directly to the center director. And so for the first time, you had that organization not reporting up through the program office, but it reported directly to center director. It turns out the Mann Spacecraft Center was the only center that did that, the human spaceflight centers. And I might just quickly point out that that didn't change till Challenger happened, because up until the time of Challenger, the other centers, the SR and QA function at headquarters and some other places was a part of the chief engineer's office. And then after Challenger, the other organizations, headquarters and the other organizations were required to organize like the Johnson Space Center had done, where the SR and QA organization was independent of the program and reported up through the center director.
Thank you.
I may have mentioned that after the Apollo 1 fire, we ended up with, I think, 1,040 changes in the spacecraft. Some of those changes, in fact, probably a good handful of those changes, had to do with the hardware and avoiding as best you could the circumstances where you would have a fire. But with that kind of delay and that kind of a fix, we began to get many, many more operational changes or little hardware things, or even like controls around the switches and things like this because of the time. And on the schedule delay, keep in mind we were flying a mission every 2 months, brand new spacecraft, and I can tell you that the general view in the astronaut office is that we were going to lose at least one of those, and this was even after the Apollo 1 fire. Expected probably lose one of those someplace, somehow, and actually did not. Apollo 13 came close, but the performance was unbelievable to be able to operate every 2 months, brand new vehicle, lunar module, command module. I was very impressed with that.
So you have a lot of changes taking place. You have schedule pressures. Glynn, how did you face the challenges of getting your mission control team ready for the first Apollo flights?
We had the set of players that were involved in the command service module had all worked on Gemini also. And when we got finished with the Gemini program, we had done everything that we could in Earth orbit. For example, we had 10 rendezvous, primary rendezvous from liftoff from the ground, but also with re-rendezvous. So we had an experience with rendezvous that really made us feel like we could handle anything that came along and where we would have to modify the trajectory or the path of the vehicle, which of course Apollo to the moon was full of. People were comfortable that they knew how to do that and could do it well. So that served us in very good stead. And the last problem we dealt with on Gemini that was pending its success was EVA. Buzz Aldrin is here in the front row, and Buzz was instrumental in some of the changes that we installed for the last EVA. We finally realized we needed a lot of handholds and footholds. We needed a better way to train. We invented a water tank of some smaller size than the present one to help with that. And that set us on after Apollo 12, which was a complete success in that regard, in the EVA regard. We were on the path to get on with Apollo, and I must admit, we came out of Gemini raring to go, both the planners and the flight crews and the ground crews, the flight controllers and the control center. There was a lot of confidence in that group, and we just couldn't wait to get our hands on the Apollo hardware. And then, of course, we had a long delay in terms of the recovery from the fire. I would say one more thing about that, which I've said to people occasionally. There was a lot of movement in Washington, D.C. as to whether they ought to cancel the Apollo program at that point. That talk finally got put to bed, and by the way, Frank Borman had a lot to do with quieting that. However, I think to myself, what would have happened had we canceled Apollo? This is as a future lesson. How would we feel about our country and about the space program? I would submit it would feel like we really screwed up. I mean, you can't take it any other way. Although decisions are difficult, they have to be made, and sometimes they're tough. But nevertheless, a positive decision on going forward with Apollo was one heck of a lot better than a decision to cancel it.
Absolutely.
Beating the Russians had a fallout that I think has benefited us for 30, 40 years since that time. And I'd like to see us get back onto the situation where we can continue to be better in space than the Russians, so we don't have to depend on them to get up and back.
We all agree with you, Walt. Now, Walt, from a crew perspective, with any new vehicle, you're going to have immature training programs. Can you talk about how you trained for those first flights and how important it was to be involved in the development process?
It's probably a little hard with today's standards to talk about how we trained for that Apollo 7 mission, because Apollo 1 was going to fly. We were just developing simulators. We had, for our crew, and after they canceled Apollo 2, we became backup for Apollo 1. And as the backup, we didn't get hardly any simulator time because there was not a lot available, and the prime crew was not getting enough simulator time as well. So as we moved forward on that, excuse me, what was the point of your question?
How you trained specifically for those first flights.
How we trained specifically for it. So we ended up having to do whatever we could in the way of getting time. That's why we spent a lot of time at the contractors, because we were there installing the equipment and testing it. You saw Frank Borman there. He and I spent many, many nights sleeping in the installation in the factory down there. So if they got something in that they were going to then start checking out, we'd get a call, and Frank and I would go down and go through that on developing the hardware to do that. Today, usually all that hardware is already done. You don't get a chance to have an input on it. And eventually we got simulators, and we started spending some time down at the Cape for the simulators. And I've read several things lately that they talk about how our simulator time. They probably don't know that I think the total we had was, our whole crew was like about 75 or 80 hours in the simulator before we got to fly. But we did have a lot of time checking out hardware.
Wonderful, thank you. And for the next question, we'll start with Frank. What enabled you to make decisions quickly and recover so rapidly from the Apollo 1 accident?
Well, as I said, it was a management change where Georgeville was put in as manager. And another good example, another giant that's still alive is Chris Kraft. He was put in charge, George put him in charge of modernize, or what should I say, unblocking the development of the software. And he set up a change board for software, much as George had set up a change board for the program, for the Apollo program. And he unblocked it in about a month. So the basic changes were human.
Gary, do you have anything to add on how we can make decisions quickly in this environment?
Well, one thing back then, the management was willing to provide a lot of responsibility to young engineers. And as been mentioned already, we had a lot better relationship working with our contractors. And so NASA project engineers were actually involved in not only running tests and monitoring tests, but also actually involved in developing the tests. And there was a lot more willingness on the contractor's point to accept our recommendations and what we were doing. And we tended to work a lot better with our contractor counterpart actually as a team member at that time. So even though we did still have the responsibility to provide the independent assessment of their work, at the same time we tried to jointly solve the problems together with them. And that, so it's a people-on-people relationship that had to be built. Yeah.
And on the lines of solving those problems, we'll go to Frank for this next question. How did you decide which changes or safety upgrades were important enough to make before the first flight?
Well, as usual in any great endeavor, it always boiled down to a single human being that made a difference. And in the case of the Apollo, the person in my mind that made that difference was George Lowe. He became the Apollo program manager after Joe Shea. And he immediately incorporated all the resources at NASA Johnson, all the resources across the board, into the re-engineering effort. He ran what was called the Change Control Board. And it met, I don't know, bi-weekly or weekly, I can't remember now. But anybody that wanted to make a change in the Apollo program had to present that engineering proposal to the board. And then all of the center project men and directors, Max Faget, Deke Slayton, and all of them were sitting there. And then they would recommend yes or no, and then George Lowe would make the final decision.
Gentlemen, what are your thoughts on which safety upgrades to make?
Well, I think we had to deal with the environment, the oxygen environment in the spacecraft, and that got done in a reasonable way. Finally, we didn't redo the whole spacecraft, but we operated a little bit differently in terms of not such a high pressure of oxygen on the pad. In addition to that, I would say that I was impressed with how the contractor and the NASA JSC at least operated then from about the fire on, I guess in terms of things that you could see. But I had seen it get to the point where the fellow who was doing most of the management of Rockwell in space shuttle times and Chris Kraft were like brothers. You couldn't get them apart. And they used each other's organization to keep their own organizations honest. In other words, if Rockwell felt very, very strongly about something that the JSC people didn't, that got a fair hearing, and vice versa also. So that Chris and George Jeffs had a wonderful relationship that served the program very well. We'd come a long way from having only the language foul be the language in use to the point where it was very cooperative, and it was very helpful, and it was very reinforcing. It was a wonderful thing to watch. It really was. People were doing things for the best interest of the program, and you had to admire that and believe that that would carry us through.
Thank you. And is there still anything that any of you would have done differently during the Apollo 1 or any of the Apollo timeframe, and any advice you have for those of us working on Orion, Commercial Crew, SLS?
Well, one thing is try to work as a team. If you're responsible for a particular system or so forth, be sure and work closely with your flight control counterpart, your contractor, individual that's involved in that subsystem, your SR and QA and safety engineer that are involved, and work together as a team to try to make your system the best it can be, making sure you don't have the single point failures there for crew safety, and being able to not only that, but know from the flight ops folk, your counterpart in flight ops, how you're going to be operating that system. The safety engineer will be identifying to you what the hazards are, and you work together to make sure in your subsystem that those hazards are controlled or mitigated. And if there's an ops control, you make sure that that's finally checked to be appropriate and everything. So once again, it's a team effort and it's an individual effort. But even going down to the smallest level, as a little subsystem, you ought to be working as a team with your group and closely working together.
Well, I think the situation has changed significantly today. Of course, the crewmen on board the International Space Station, I assume that many of them have something to do with the design of the particular experiments that they're going to be operating. But it's rotating people in and out, and so it's a whole different situation from working with the spacecraft and what have you. So I think what the most important thing to do is to find some way so that everybody feels on the same team like we used to back in those days, as opposed to you come in and you just focus on one particular area. There may be a lot of things going on that I don't know about now, but when I look back on it and the way we did it then, I just feel fortunate that I lived when I did.
I would say on that question that one of the things that you really have to manage is time, because you know, in terms of the Apollo program and every other one, there's just a flurry of activities, and big things and small things come at you in the same kind of, with the same kind of speed, and some things are more important than others, and getting to the prioritization of what you should be dealing with and what you should be paying attention to is something that everybody ought to be tuned into, because it's where things get lost. I mean, the answer for flying with oxygen and 16 pounds was, well, we did it on Mercury and Gemini and it was fine. And that was the closing argument. In retrospect, not the proper argument. But that would be something that might carry you through, not looking at it. So we got to be careful about those kind of conditions where we think we have the answer when indeed we really don't, and we ought to be open-minded about re-reviewing that.
Well, there's one thing we did. We operated in those days at 5 psi on 100% oxygen. Today, in the space station, I think they're operating on kind of a regular atmosphere. And they're up at 14.7, 16 psi. So it's a different kind of a business for survival. You still have to focus on the safety of it. But I don't think we're ever, again, going to go to 100% oxygen tests on the ground like we did then.
You mentioned the Gemini and Mercury programs, and Apollo was right on the heels of those programs that were very successful. Can you talk a little bit of maybe how that kind of set our safety culture and if that lulled us into a false sense of security?
Well, one factor that I can think of is while I worked a little bit on the engineering during Gemini, from the time I got appointed to a crew on the Apollo program, we depended on what was going on, and we took it for granted that they were going to succeed at it. You know, the rendezvous, docking, EVA, and we just counted on everybody succeeding in what they were doing, and they were driven that way. I'm not sure anymore. I don't know what the psychological aspect is here these days, but in those days we were damn glad that everybody was a fighter pilot and had that kind of experience, because we expected losses and we expected to go on in spite of any losses.
Thank you. And now I'd like to give you each an opportunity to share anything else that you would like to with the audience, particularly with an eye towards the future of spaceflight. And we'll start with a recording from Frank.
You know, I'm not presumptuous enough to make any suggestions because I don't have the knowledge or the information. But I would suggest that that people that are involved in the future take a look at how the Apollo program was run, because I think it was a management program that was very, very successful, particularly after the fire. Before the fire, the Apollo program was sort of insular. It was, as I mentioned, not integrated enough into the center, into Johnson Center. And a lot of the decisions were, Joe Shea went right to George Miller in Washington, this doesn't work. I remember one time I had a long conversation with Dr. Alexander Lippisch, who was a German scientist who designed the Me-163 rocket airplane. And he told me, he said, you know, in his German accent, you have to make certain that you don't run across what we did in Nazi Germany. And I said, what's that, Dr. Lippisch? He said, all the decisions had to be made in Berlin. He said, remember this? But then I was a major. Remember this, Major Borman? Make the decisions at the lowest level where the information exists. Don't become incensed with the Berlin complex. And I think that's right, because if you look at the Apollo resurgence and the Apollo success, primarily due to the people at the center level, George Low, Dr. von Braun, Dr. Gilruth, Chris Kraft. They're the ones that made it happen.
And in our final minutes, gentlemen, do you have any closing remarks or any other lessons learned you'd like to pass on to the next generation?
Well, I would salute Frank in that regard. I talked about what the future would look like, or today would look like, had we canceled Apollo at the wrong time. But when that was being debated, Frank testified and said something like, look, the spacecraft is ready, the people are ready, the systems are ready, we've done everything we know how to do, and we're asking for your permission to go fly. Now, do you have faith in us, or don't you? Period. And question mark. And there was a little conversation like that, I suppose, at the time, and they went away to think about it, and lo and behold, very soon the Apollo program was back on full bore. And Frank had something to do with that, and he was an effective articulator of what the situation was and what was at stake, and asked them if they had the confidence to go ahead, because we did.
Well, I think one of the major factors back in those days for Apollo is we were willing, we had the mental attitude to push through the next frontier, going to the moon. And today, 40 years later, we're still benefiting from what was developed to do that. And a major factor in that time was we were competing with Russia, of course. We need to find some other motivation to push the next frontier when and if it makes sense for humans to be going and doing that. Because when we landed on the moon in 1969, then believe me, in the office, our general attitude is we'd probably be on Mars by 2000. They pushed some earlier dates, which we never believed, but by 2000, sure thing. I'm not sure when we're going to be able to go land on Mars, incidentally. And I think that our unmanned program out there is doing a wonderful job considering. But we have to develop the technique to be able to do that if we want to keep our attitude correct to open the next frontier. Personally, I think that we ought to be trying to develop a habitable spot on the moon to help develop all the things that we need to do to go to Mars.
Gary, we have about a minute left.
A couple of things I'd pass on is, and I believe we're following this nowadays, if we have some major accident or investigation, we want to share those results. There was, and most people don't realize, we had an ECS subsystem fire in a pure oxidative environment almost a year before the Apollo 1 fire. I was involved in the investigation, but that report that came out, the board report that came out, was classified. I myself, even though I was involved in the investigation, never got a chance to see what my write-up was in regards to the wiring, and never did actually see the actual report. And when even you hear talk about Apollo 1, there's no mention that we had this situation occur that we could have had some lessons from back then. And the other thing is for the Orion program nowadays, to go back and study those lessons. I just here in the last 3 or 4 months, going through my files, ran across a report of a very close call we had on the Apollo 11 mission, almost nobody knows about, and that includes the people involved in the Apollo 11 mission, because the results of that didn't come out too much later. And it had to do with the fact that the Apollo 11 crew reported, hey, we just saw the service module go by, okay? And this is during the entry corridor, which was a big shock to the people involved in the debrief at that time. So they went off and ran an investigation looking at reports of aircraft monitoring and the radar and so forth. And sure enough, the service module was going into the same entry corridor as the command module. And that all the evidence before that and analysis had showed, because of the active controller we had on there, is supposed to be far and away and actually skip out and be nowhere close to that. So don't forget when you jettison that service module that you make sure there's something there to make sure it's not going to hit you later.
Thank you, Gary. Thank you. And gentlemen, thank you all for your time today and for your thoughtful answers to these very important questions. We will definitely take the information you gave us to heart as we move forward with the next space program. And in closing, we'd like to share one final clip from Frank Borman about the significance of the sacrifice that the Apollo 1 crew made.
Well, I think that everyone should recognize that the Apollo 1 disaster led to the changes in the spacecraft that made our program successful. And the three crews didn't die in vain. The three crew members didn't die in vain in that program. They were really pioneers as much as anybody that flew. And it was a tragedy of the highest magnitude that was attributed to human error. And it's just unfortunate that these brave people had to pay the ultimate price.
Two quick things. First of all, you can find a link to the accident reports for Apollo 1, Challenger, and Columbia if you go to the SNMA website at JSC and look under Day of Remembrance. So I recommend, if you have not seen those recently, you should take a look at those. Also, we're about to head over to the Astronaut Memorial Grove. I would like for the audience to remain seated so that the family and guests can get out first, and then the rest of us will head on over. But in close, how about a round of applause for our excellent panel, and thank you for their work. Thank you.